Welcome to another video. Today we're going to set up a very simple character with control inputs to allow you to simulate a third-person character of your own design. You could also use this control scheme for a first-person character with just a few tweaks. I've started an empty project here, and I'm going to begin by creating a new level to start working and testing in. File, New Level, and I'm just going to choose the basic level here without the open world features. When you create a new level, it will not have appeared in your content browser yet. I can open the content browser by using the shortcut Control Spacebar. So before I can continue any further, I'm just going to save this level by going to Save Current Level, and I'm just going to call this L1 for my first level. Now it's in the content browser, I know I can come back to it, and I know it will save when I save the project. Okay, so we're going to begin with our own character. I want to start by placing a player start location so that when I press play to test this level, I can control where the player will spawn instead of having to place the camera where I want to and then press play to begin. I can find this under the quickly add to project drop down, and when I come down to basic, I can find the player start option from here. I'm going to drag and drop that into the level. Now when I press play, I will start from the player start location. Because we have a completely empty project with no characters set up in it, whenever I do press play to test this level, I will spawn in as the default spectator pawn. What I want to do now is create my own character instead to use. So I'm going to open the content drawer, I'm going to right click, and I'm going to create a new blueprint. This is going to be a character. Here in the Pick Parent Class option list, you have many options to choose from, and the two that we could use for a player to control are the pawn or the character. A pawn is a very generic and basic class that can receive input from a player, so if you wanted to completely build your own character from scratch without using any of the other pre-built subsystems in Unreal, then pawn may be the way to go. But the character component already has the ability to walk around and to manipulate many other factors of a character's movement, such as jumping, built into it. So I'm going to start with that since this is a beginner's intro tutorial. I'm going to call this BP player character. I always start with BP on blueprints because that stands for blueprint, and I've given it a predictable and obvious and very clear name, player character, because this is going to be the one that the player is controlling. When your projects become very complicated, you'll be grateful that things are clearly named when you're searching through your content drawer to find things. So if I double click on that, I can open up the blueprint editor for my player character. By default, it will pop up in a new window like this. I don't like having to flick between multiple windows to open, so I am just going to dock this player character window by clicking on the tab at the top, dragging and dropping it next to my level, and now I've got my level. Sorry, my character docked next to the level, and I can flick and switch back between those two nice and easily. By default, this character simply contains a capsule and an arrow. Over here in the components list, we can see here is the capsule, here is the arrow, and there's one extra component here in this list that we can't see at all, the mesh. This is a character mesh component which is expecting a skeletal mesh as an input. I don't have any skeletal meshes in this project. Instead, I'm going to very simply add just a static mesh that we can use to preview our character and make sure that it's moving around and doing what we expect. So in the components list here, I'm going to click Add, and I'm just going to select Cube from the list. And there we have it, a magnificent player character. Underneath this list of components, we have a final component here, the character movement component, and this is the biggest difference between a pawn and a character, is the addition of this component. This is a fairly complicated component that allows you to handle networking and movement and, like I said, jumping, and it gives us all of these options and the details on the right hand side here, but we'll come back to that later. For now, let's just take a look at this components list here on the side. When I added the cube, I had the character mesh selected, so it has been added as a child component of the character mesh. I don't actually want it to behave like this. If you want to rearrange components here in the components list, it's easy to just click on them, click and drag and move it to where you want it. I'm just going to drop it onto the capsule component, which will now remove it from the mesh, the character mesh, and has made it a child component of the capsule and of nothing else. This can create some problems when you're scaling objects if their parents have different scale to the child object, but understanding the hierarchy and being careful in how you place things can save you a lot of trouble later on down the line. So we have our simple character here. How can we get it to spawn in the level? I'm just going to compile the blueprint and then save my changes. If I come to the level and hit play, our character still hasn't spawned in. I am currently spawning in as the test character. So why is this the case? If you come to Edit and open up the Project Settings window, it will again pop up in a new window. So just like with the player character, I'm going to dock that next to my level, so I've got all three of these open at once. Here in the Project Settings, this is all of the features that you can tweak for the entire setup of your project, and there's a few very useful parts that you'll want to come into at the start of a project. For instance, right here at the top we have an option called Maps and Modes in your project options. This is where you can choose which map is open when you open this project next time you open Unreal. Currently it's going to open the open world template level that we spawned with right at the start of this video. I don't want that. I want to use L1, this new level that I just created, and then you can also set which map would be the default game map if you were to ship and sell this product, in which case it would probably be something like your loading screen or your main menu. I'm also going to set that to L1 just for the sake of making it nice and simple. But above it here we have this option called Game Mode. The Game Mode is created inside the game instance. It's one of the first things loaded when a level opens, and it contains a number of controls. If I open up the drop-down list for selected Game Mode, I can see that this game mode base class has a default pawn class set to default pawn, a HUD, a player controller, a game state, and a spectator. The only important one for us now is this default pawn class. This is grayed out and can't be changed at the moment because game mode base is one of the engine classes built into Unreal. So if we were to start changing these, we would literally be editing the engine's default settings. So in order to change this, we're going to need our own game mode. So I'm going to open up the content browser by pressing Ctrl and space. I'm going to right click, select Blueprint class, and choose on this list Game Mode Base from the list. I'm going to name this new blueprint BPGM for Blueprint Game Mode. I'm going to press Ctrl S just to save it. When you open up this blueprint, it is again an empty blueprint with no components in it, but on the Details panel here it has all of these classes defined. So for us to use the new BP player character that we have just created, I will need to change the default pawn class to my BP player character. Compile and save that blueprint. Now in my project settings I can change this game mode base to my own custom one, BPGM, and automatically you can see that my default pawn class has changed to the one that we set it to be earlier. So now, let's test that instead. When I press play, I spawn in, you can see my cube at the bottom of the screen, and my controls don't do anything no matter what I press, which is exactly right because we haven't added any controls to this project yet. So, let's fix the camera placement on our character. Here's our cube attached to the collider, the capsule. If we were to just come to the components list, and you might think, great, what if I add a camera? And I place this camera somewhere behind my cube, looking down at it. Brilliant, maybe that'll work. And yes, I do get a better view of the cube here. But this is going to create problems later on in your controls. For example, what if you want to rotate the camera around your player? Then you'll need to move the camera and keep it pointing at the player, no matter where the player moves their mouse to or adjusts the controller on their thumbstick. It's going to be a real nightmare to keep the camera pointed at the player. So instead of doing this, I'm just going to delete this camera. Unreal has a very handy feature called a spring arm. So come to the components list, I'm going to select the collision cylinder so that this is a root component, and add a spring arm. And this red arm will be added to the cube. A spring arm is a very useful little component which carries out basically checks to see if it's obstructed, and it will shorten itself to get past any obstructions. This means if you look up with the camera, instead of clipping through the ground when you rotate the camera up, the spring arm will shorten and the camera will instead be brought closer to your character. You've probably seen this mechanic in many games. So now we have a spring arm. Select the spring arm and add the camera to it manually. If the camera is not a child of the spring arm, now is a good time to make sure that it is. For example, what if you had the capsule selected when you added the camera? Well, now, if I move the spring arm, the camera doesn't move. But if I attach the camera to the spring arm, now it becomes a child component of the spring arm. You can see it's underneath it and indented slightly on the hierarchy. And if I move the spring arm, the camera moves with it. And that's how we get our nice, predictable camera movement where it's always facing at the player without having to do lots of maths and continually point the camera at the player manually. Well, through code, sorry. So our camera is set up. If I press play now, we should be behind our cube with the camera looking at it. We still can't move yet, so let's begin to add some controls in. We're going to, for the sake of this project, use one of the legacy control input systems built into Unreal, just because it's much simpler than the newer, more complicated, enhanced input system. To add these legacy controls, go to your Project Settings window. If you've closed this, you can access it through Edit, Project Settings, or you can get to it from the main editor window by coming to the Settings panel up here and clicking Project Settings. And underneath the Project Settings, come down to the Engine section of the list on the left-hand side, and the Input tab will be somewhere in the middle of this list. On my screen, it's right at the bottom if I don't scroll down nice and handily. So you'll get this warning telling you axis mappings are depreciated, use the enhanced input actions and input mapping context instead. Yes, I know, but for the sake of a simple introduction, these are a very nice way to ease you into using blueprints and the event system in Unreal. So, input settings. This is where we set up our bindings, our control inputs, and there are two different kinds in Unreal, action mappings and axis mappings. You can think of them very simply by looking at any kind of game controller or keyboard. The axis mappings are analog sticks, movement here, and they range from -1 to +1, whereas action mappings are a single button press. They are either on or they are off. So an action mapping will be for something like jumping or firing, whereas your axis mappings will be anywhere where you need more gradual control, 0 in the middle, +1, and then all these leg gradations in between as you move the stick more gently. So very useful for analog movement or for throttles in vehicles, that sort of control, anywhere where you need more subtle control movements. So we're going to start with an axis mapping. Click the little white plus button to add the axis mapping. You can tell if you have any axis mappings because the white drop-down arrow will appear. It'd be really useful if it automatically dropped down, but it doesn't, so oh well. And here is our new axis mapping. I'm going to name this my forward back axis. Again, it's a long, obvious, boring name, but it's very clear what it does. By standard, we have no key presses set up. You can set your control bindings in one of two ways. You can either choose a key from the list, so I can come to keyboard and I can keep scrolling down, or I can use the search bar here to find keyboard W. There we go. Or you can click the little keyboard icon here next to the input and it'll go yellow, and then the next button that you press, it will record that key instead. So I can just press any button on my keyboard to select that. And yes, it's very easy to accidentally click twice and bind your left mouse button to an axis. So I'm going to use that shortcut key to set up W, and the scale for this will be 1. So when I press W, we will push that axis up to 1. I need a new axis mapping. This one's going to be S, and this is backwards, so I'm going to move that scale down to -1. If you remember the controller, we're going from -1 to +1. So that's going to be forwards and backwards. Let's make use of it. If I come over to my character, here in the main viewport, I want to switch over to the event graph. This is where we start doing our coding. You can get to the event graph one of two ways. You can double click on it in the left-hand panel where it says event graph, or up at the top here next to the viewport and construction script tabs, you have the event graph tab. They both take you to the same place. I'm going to just delete everything on the screen because we don't need it for now. So click and drag a box around it and hit the delete key. And we're going to now search for our newly created axis input. So if I right click and I search for my forward back axis, I can find the forward back axis event. These red nodes in Unreal are the event nodes. They drive almost all of the behavior of the engine is through these events. They are triggered when something happens and they are used to set off other pieces of code. So in this case, this is a constantly polled axis that is checking to see what has happened to that axis here. And we can get a very quick look at what is going on by using something called a print string node. The print string node is your absolute best friend when debugging. It has inputs on the left-hand side and outputs on the right-hand side here. And as an input, it is expecting a string. Currently it says hello. But if you drag from the axis value here, this is the value that's currently being output by our control axis, and drop it into the in string. And then we connect up the executionable pins from left to right. So this works as a flowchart, always moving along the executionable line. Whenever this axis updates, we will print a message onto the screen, which will allow us to see what the value of that axis is. Easier if I show you. If I hit play now, I get this list of numbers down the left-hand side of the screen. And if I press W to move forwards, I don't move, but I can see the axis has changed to 1. And if I hit S, again, I don't move backwards, but the axis is changing. So we know our controls have been set up correctly. We have a range between -1 and +1 to play with. So let's use it to do something, shall we? I'm going to get rid of the print string by just selecting and deleting. And I'm going to take this event, drag off the executionable pin, and look for a node called add control input. Add movement input. This is again one of these nodes that is particular to characters and pawns. So add movement input. If we look at this node, it has the inputs on the left-hand side, outputs on the right-hand side. It is expecting a target currently. I'm going to leave that as self because we want to move the player character. That's this blueprint that the node is in. It has a world direction, which we're going to set in just a second, a scale and a force. A force will be used to shove your player around even if they wouldn't normally be able to move, so we're going to ignore that for now. And the scale value is very important. We can use that, it's currently set at 1, so it multiplies the world direction. So currently at 1, whatever we put in here will be times by 1, so essentially unmodified. So you might think that we could just change the x value here to 1, but that will only move us in the world x direction. So if I place a shape into this world here, a cube, and we can see that the world x direction is along this red arrow here. But if I rotate the cube at all, the world x direction is still the same, even though the cube should now be rotated and facing in a different way. So we can't use hard-coded values here. We're going to need to fetch the player's current facing. Otherwise, they won't be able to rotate and continue moving in the same direction. This is easy to do, though. If we right-click anywhere on an empty space in the blueprint and search for get player pawn, we get a node which grabs player index 0 and returns a value which is a direct reference to the player character in the current level. Player index 0 is always the local player. You only have to worry about your player index if you are doing multiple players on a single computer for local multiplayer. Even for online multiplayer, player index 0 will always get the current player on whichever machine the script is running on. So this is a reference directly to our player character, and if we want to know which direction they're facing, it's a very easy node called get actor forward vector. In fact, I think you can find it if you just type forward. And this will update constantly. Every time it is called, it will get whatever the current forward vector is. So if we plug that into our world direction, we can now test it. Our player is always moving forward. So that's working. We are currently able to get our forward direction and go that way. We're always moving because I'm multiplying the world direction by 1. So every time the axis is poled, which is pretty much every frame, we are moving forwards by a scale of 1. If I can use the axis value here instead, which remember goes from -1, 0 when we're not touching anything, and +1 when we do push forwards, we can multiply this world direction either negatively to go backwards, by 0 when we don't want to move, and then by 1 when we do want to move forward. I'm going to compile the blueprint, save it, and play. And now W and S will move me forward and backwards in this world, just like I'm hoping for a forwards and backwards controls. Now we need to duplicate everything we've just done for left and right movement. I come to the project settings, I add a new axis mapping, I call this my right-left axis. I need 2 control inputs. One is going to be D for right, one is going to be A for left. Left needs to be negative. Then I come to my player character, right-click, search for my right-left axis. I want the event, not the value. I'm going to search for add movement input. This time, though, we're moving right or left, so I can repeat exactly this process, except instead of getting the forward vector, I'm going to get the actor's right vector. That's another tool built into the engine for you. So get player pawn, get actor right vector, and then the axis value in there again. And it will multiply it in exactly the same way. And if I compile and test that now, we have 3D movement, forwards, backwards, left and right. So I'm going to comment this code up so that it's easier to understand. Handle forward, back movement. And because that's all of the player's movement controls, I'm going to wrap them in a single comment as well. You can add comments to your code by selecting whichever nodes you want to add a comment around and then tapping the C key on the keyboard. And you can edit the color and font size of your comments over here in the details panel on the right hand side, including the alpha if you want to make comments more transparent. Okay, so that's the movement input handled. Now what about mouse input so that we can actually look around? So I'm going to do the same thing again, but this time I want to grab a mouse axis instead of a button press. So I'm going to add 2 new axis mappings. The first one's going to be my mouse X, second one my mouse Y. And you can't use the little button to detect a mouse axis. It's looking for the next key press, so I can't detect when I'm moving the mouse by using this auto detection. So I'm going to have to instead come to the drop down menu, find mouse and select the relevant mouse axis manually to make sure you've got them. And you don't need to worry about the scale. The mouse will automatically be able to send negative values. So we've got our mouse X and Y axes. Let's try plugging them in here. So the controls that we're going to use here are slightly different. We're not adding movement input this time. We don't want to actually move the player. We just want to rotate them. So if I search for my mouse X axis event, and I can add controller, and here we have 3 different types of controller input. Pitch is looking up and down. Roll is rolling your head from side to side, and do a barrel roll. And your input is actually looking from left to right. So for my mouse x-axis moving from left to right, I actually want to use your input. And you can just plug the axis value directly into the value for that, and we can test this. There we go. I can look left and right, and my movement is unaffected. I'm able to now circle strafe and look at one object while moving left and right. So far, so good. Can select the nodes, press C to add a comment. And things get slightly more complicated now for the y-axis. What we don't want to do, if I just come to the viewport, is adding your input to move the player left and right works perfectly fine for rotating the player for looking to the left and right. But when we want to look up and down, we don't actually want to add pitch input to do this. Otherwise, your whole player would start to lift up and down and tilt forwards and backwards whenever you wanted to look up and down. To the extreme case, this would mean if you looked right up in the sky, your character's feet would lift off the ground and you would be hovering. So you don't want to move the player's character at all when looking with the camera. You might want to do some clever stuff animating the head and keeping it looking at a specific point, but if you've got a fixed mesh like this, we don't want to move the character when we look up and down with the camera. We just want to move the camera. And our camera is attached to the spring arm, so this can handle our up and down looking movement for us. So rather than use the control input, now we're going to actually use some of these components that we set up earlier in order to allow our camera to look up and down. So if I right click and I search for my mouse Y, now that we have the Y axis, this is the first time we're not going to be using one of these controller input nodes. We want to manually adjust the rotation of one of the components in our character, and in this time that component is the spring arm. So you can either select the spring arm from the components list or from the variables list down here. Select it, click and drag it into the blueprint, and you'll be met with the menu asking you, do you want to get the spring arm or set it? This is the same as read and write. We just want to read the spring arm. We want to know what it's currently doing so that we can access any functions that we can use to affect it later. And in this case, that function that we want is going to be add local rotation. The add local rotation node will cause this spring arm to rotate just like I'm doing here in the viewport test, regardless of its world position. The delta rotation that it is expecting as an input to this node, inputs on the left, outputs on the right, is expecting a rotator. A rotator is an x, y, and z value all combined into a single variable. We don't have a rotator. We only have one axis value here. There are 2 ways of feeding a single axis piece of information into a rotator that is expecting 3 values. The first one is to take your axis value and search for the make rotator node. And using the make rotator node, you can plug the axis value into the roll, pitch, or yaw. This is the mouse Y axis. We want it to go into the pitch angle, and we can plug that in like that. This will accept this new rotator without issue. The other way of doing this, which is somewhat easier and requires less nodes, you can split rotators like this or vectors into their constituent parts by selecting the pin, right-clicking on it, and splitting the structure pin. Now we can access the X, Y, and Z values of the rotator individually and just plug our axis value into the pitch here. Compile the blueprint and save it, and let's test that. I can look up and down, left and right, and I can move around. I have a functional third-person character that I can use to immediately start testing. It's not perfect, but it will do, especially for a beginner starting out. Just as a bonus then, let's add an action mapping into this list here. We already talked about the difference between axis mappings and action mappings. In this case, let's add a new action mapping. Drop down the little arrow to view it. Drop down the arrow again to see which key is bound to it. I want this key to be the spacebar key, and I'm going to call it my jump event. Oh, sorry, jump action, that should be. If I come to the player character here, mouse look Y, so those two are the camera look controls. And I'm going to find a new empty part of the blueprint over here, right click and search for my jump. There's my jump action. And the node to get your player to jump is extremely predictable. When the player presses jump, I'm just going to call the jump function. It's got an F next to it here, so you can tell it's a function. And that's it. Now if I compile and test this, our cube should be able to jump and look and rotate and leap around my new empty level.